It is now my distinct pleasure to welcome our keynote speaker, Dr. Patrick Biery. As a homegrown Minnesotan and an alumnus of the College of Liberal Arts, Dr. Biery received both a Bachelor of Science undergraduate degree in 1993 and a PhD in economics in 1997. Today, he is an applied econometrician working as chief economist and vice president for Amazon, the largest internet-based retailer in the United States. His team of PhD economists use applied econometrics to help Amazon better serve their customers and operate more efficiently. They have collaborated with other Amazonians to develop technically advanced but practical solutions in operations, pricing, forecasting, applied marketing, and merchant services that currently power their platform. This past November, Dr. Biery was elected a Fellow of the Econometric Society, which is a great distinction in the field of economics. He is a research fellow at the National Bureau of Economic Research and has served as a consultant to the Boston Consulting Group, the Federal Reserve System, the Law and Economics Consulting Group, and the U.S. Federal Trade Commission. He has published research in leading economics journals on collusion, differentiated product demand estimation, auctions, and methods for the empirical analysis of strategic behavior. Prior to working at Amazon, Dr. Biery was a full-time academic working in applied econometrics and empirical industrial organization. Dr. Biery currently holds an affiliate academic appointment at the University of Washington. He has held previous positions in the economics departments at Harvard, Stanford, Duke, Michigan, and our very own Department of Economics in the College of Liberal Arts at the University of Minnesota. His expertise in his field, as well as his experiences both in academia and the private sector, give Dr. Biery a unique perspective on what faces you as graduates going out into the world today. Pat, it is an honor and a privilege to welcome you home. Please join me in welcoming Dr. Patrick Biery.
Thank you very much for that warm introduction. And first of all, congratulations to the graduates. Today, you're being awarded a prestigious degree from a world-class university. But more importantly, in the process of earning that degree, your lives have been forever changed. You perceive the world in a completely new and more subtle manner. And also, you've acquired a new set of skills through the process of writing original research that allow you to invent and in turn contribute to both our society and our economy. In this journey, you've been supported by your family, friends, fellow students, and faculty. But today, I'd also like to give thanks to this magnificent institution, the University of Minnesota, and the generous citizens of this state that have supported it for more than 150 years. The U forever changed my life as well as yours. I'd like to express my gratitude by sharing with you a couple of memories of my time here. I grew up on a farm in central Minnesota, about an hour and a half to the west of here, and I have many fond memories there. However, I would not describe myself as particularly worldly at the time I arrived at the University of Minnesota. For example, when the movie Fargo came out, I did not realize that the actors had particularly strong accents. I thought most people just talked that way. The U broadened my horizons to a bigger world and helped me become an independent thinker and researcher. Some of the memories I have are, as a college junior, listening to Professor James Dickey, who trained me in classical statistics. Jim Dickey gave me a toolkit that I use every day as a working econometrician. For those of you who knew Jim Dickey, he was quite a committed Bayesian. And for those not versed in statistics, classical statisticians and Bayesians do not see eye to eye. As he was teaching us classical statistics, he would give beautiful explanations, and then he would turn around almost immediately and explain why that concept was almost completely wrong-headed. I learned that in education and statistics can be humorous, if even inadvertently. I remember spending the summer of 1990 in Vincent Hall with the windows open, learning real analysis from mathematics professor Max Yodite. Max taught us about truth tables and about how to construct a logically rigorous argument in mathematics. He forever changed my view of what it meant to put together a logical argument. Also, he exposed me to a form of beauty I never would have anticipated in that terse, precise, and general sets of theorems in that course. I remember working as a teaching assistant in microeconomics for Leo Hurwitz and discussing macroeconomics with Ed Prescott during department happy hours in Seven Corners. Both Leo and Ed were later awarded Nobel Prizes in economics. And I count myself as very fortunate to have had the chance to take classes from them and spend time with both of them. Ed and Leo taught me something very counterintuitive, which is when you're analyzing very complex problems, you're often best starting out by working with simple views and simple models. Those models should have a handful of key assumptions that are well thought out, and you should work through the logic completely. After you understand the weaknesses from these simple viewpoints, you move outwards towards solving more complex problems. On behalf of the graduating class and its alumni, I'd like to thank this wonderful institution for profoundly changing my life, and also to the classmates, teachers, and advisors who helped us all become independent thinkers and researchers. In commencement speeches, it seems customary to do one of two things. Either you give an inspirational message, or you try to talk about something you know. Economics is sometimes known as the dismal science, so an inspirational message seems out of turn. Therefore, let me talk a bit about the economy. The history of the U.S. economy since 2008 is not a pleasant one. We suffered through the worst downturn since the Great Depression and have seen thoroughly mediocre economic growth since then. Many before me have commented on those events, and I shall not repeat them here. Today I'd like to talk about something that's more hopeful and something to which many people in this room, our new graduates, might be contributing, and that is new technologies operating at the boundary of software engineering and quantitative fields such as stats, math, operations research, and even some economics. From my personal view, albeit limited, this innovation is occurring because distinct disciplines are now interacting. Software engineers are borrowing modeling techniques from the quants, and they're learning to use their data more intelligently to make better decisions. The quants, in turn, are learning to solve problems at much larger scale by using modern and appropriate tools in engineering. These tools are variously referred to as big data, machine learning, or other names. As consumers, we interact with these tools as customers of companies like Google, Facebook, Apple, Uber, or even Amazon. But in the background, they're also transforming almost every industry, many of these less visibly, ranging from agriculture, trucking, health, or manufacturing. I'd like to so many people have commented about these tools, but there's less clarity about the forces that are driving the adoption of these tools across these industries. And that's what I'd like to talk a bit about today. From my viewpoint, the spread of these tools are being driven by simple economic forces that would have been recognizable to Ed, Leo, or even the microeconomists at the start of the 20th century. Let me try and paint a simple view of the classic themes that I see at play. As I mentioned, Ed and Leo taught me when looking at a very complex problem, start simply, work through your logic, and see where it takes you. Let me first describe how I see some of the moving parts. A fundamental feature of these new technologies is that they're often applied when there are very, 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 very large number of choices. For example, they're on the order of 800 million unique items for sale on eBay in a given day. A customer on Apple can buy 26 million unique songs on iTunes. There's 1.6 billion people that you connect to on Facebook. There are many other examples in the background that we don't face as consumers. For example, an operations research scientist at FedEx may have more ways to configure a transportation network and the routing of its packages than there are atoms in the universe. A farmer fertilizing his field in Minnesota can decide optimally the number of seeds and amount of fertilizer to plant per square foot. A second corollary observation is that when you have a very, very, very large number of choices, many of those choices are wrong in the sense of being inefficient. For example, if Facebook wants me to help identify a high school classmate from the small town I grew up in, that's 100 people. So there's 1.6 billion minus 100 ways to make that decision incorrectly. If I'm browsing for a book on Amazon on microeconomics, and the system should present me a work by Leo Hurwitz, that represents 1 out of 30 million choices. Making a good, rational, and efficient decision in these environments is akin to like what we used to say on the farm, finding a needle in the haystack. The number of wrong choices massively outnumbers the handful of efficient choices. Given that background, let me talk about a couple of simple principles from economics. A first principle Ed and Leo taught me was when viewing economies, think of firms as attempting to avoid waste. While this masks the complexities of group decision-making, it is a very simple and useful starting point. For example, Facebook probably wants to recommend friends to me that have a high likelihood of finding relevant, and that OR scientist at FedEx probably prefers configuring his trans network in a way that generates lower costs than higher costs. What these new tools are doing is allowing us to make good decisions at a very large scale. And given the scale of these problems, that's why there's a gain from combining disciplines, because you can make better decisions by combining the tools from these quantitative disciplines with software engineering. In my work, I see interdisciplinary collaborations between quantitative PhDs and software engineers on a daily basis. A second principle Ed and Leo taught me was when there's competition in markets, which is not always, on average, more efficient firms grow larger and survive longer. Armed with these tools, firms can make increasingly better and more rational decisions. And in doing so, they expand the demand for their products and reduce the cost to produce them. Some firms will choose to adopt these technologies, while others will not. Those firms that adopt these technologies will tend to make better decisions and, on average, grow faster. Those that do not will tend to shrink. This generates a feedback loop in markets that diffuses these new scientific methods through the economy. These methods allow consumers unprecedented choice and allows us to solve problems that would have deemed impossible a decade ago. And also, from my viewpoint, we are in the very first innings of creating these tools. I am regularly confronted with problems that do not have complete solutions in the literature, and some of them have not even been formed. A final thing that Ed and Leo taught me is there are always trade-offs. I've just discussed the benefits of these new technologies, but there are also costs. In displacing less efficient technologies, some workers will lose their jobs, and they face real economic costs. Another trade-off is that we're generating increasing amounts of data about ourselves, and this is a real cost in terms of our privacy. Costs from these new technologies are real, and there will be bad actors using these technologies. But I'm an optimist and suspect that when the history of this time period is written, many will judge that the benefits will exceed the costs. For many of our graduates, it's worthy to note that the key innovations, a large number of the key innovations in this area were produced by people like you, new graduates with advanced degrees from major research universities. I suspect in many cases, the breadth and power of the inventions they created shocked the inventors themselves. Armed with your education, all of you have the ability to change the world as well. I suspect many of you will be surprised and delighted by how the ideas you've created benefit your fellow citizens. You're entering into exciting times, and I wish you all the best. Thank you.